Hello, my name is Timo Vogt. I'm happy to do this presentation for Digitalize in Stockholm 2023. The project I present is called HumanScatter. This is joint work with Ilva and Anders, as well as Saptarshi and Femi. Our goal is human-powered interaction using backscatter communication. Human-powered interaction has been around for a very, very long time. You can see some examples here on this slide. However, there are new tools and principles and demonstrators based on backscatter communication that we want to develop so they can actually connect this human-power interaction to some modern devices. So, as mentioned, this is human-powered interaction has been an old form of interaction with media. But what is new and what we want to explore are just-in-time and off-grid settings. For this, we're devising a new transceiver, we're devising multiple demos and scenarios, as well as new tools. The starting point of our project is earlier work on manual-powered interactive media that has been done at KTH. So here you see various examples of work that has been done. But there has always been one big problem, that the power consumed for communication has been quite expensive and has made it difficult to make these devices really, really battery-free, or rather to make this interaction battery-free. So what we want to do is we want to put backscatter communication into place. Backscatter communication has the possibility to drastically reduce the energy consumption for communication. The main idea is that it is very expensive to generate a radio wave on which you modulate the data. So what we're doing in backscatter is that we're actually outsourcing the generation of the carrier wave to an external device. Then we have a backscatter tag that, by reflecting or absorbing these carrier waves, modulates its own data on top of this carrier wave and sends a backscattered signal back that can be read by a receiver. So it has early been showing that these types of protocols actually reduce the energy consumption drastically. In particular, if you're sending several messages per second, right? The more packets you send, the more you can save, as these two examples here shown. So what we've been doing in this project is that we have devised a new backscatter architecture that makes it a little bit simpler to program these applications. What you're doing is that you're putting the data in your payload into a packet. Our architecture adds the header and adds some security options, and then you give this packet to the radio friend, and that then backscatters the data that you want to send. At the same time, there have been quite some conceptual design activities about human-powered interaction going on at KTH, with workshops and with students working on that. Here you can see one example, and this is an active loudspeaker that's powered by a crank. This also does not only make the interaction more fun, but it also helps you to with privacy by having the device just turned on when you really want it to be turned on. Other examples include a manually powered NFC reader, where you are not dependent on that you are on the grid, right? So even if there is no power available, this would work because the human is actually generating the power for these electronics locks. Recent progress has been that we have been making new hardware, where we have been making the carrier wave human-powered. This has been done with a simple crank. We've also provided new software that sense in which direction you're actually cranking. And based on this, you're sending your packets on 2 different radio channels, depending on in which direction you rotate. We've been exploring application and use cases. You've already seen the wireless logs, but in the next example, we will also show some simple game. So here's a video. What you can see in this video that we're having here, the crank, right? This is a device that generates the carrier wave. Then we have the backscatter tag, and depending on the direction you crank, either this nodes receive it or this node receives it and can then interact with, for example, an e-ink screen. So let me just run the video. So you can see here now that the person starts cranking in one direction and the tag backscatters its data to this device. Now you're cranking the other direction and the data is sent to the other device. This allows us to do some simple games where you're actually using the crank. I guess you've all been playing these games, but I assume nobody has ever used backscatter technology in order to do that. So this is one example of a game. Here we have a different game where the direction of cranking determines if this small ball is going up and down. So this is another game that is made possible and that you could play then using your human power to determine what's going on in this game. Let's not run it again. So with this, I want to thank you for listening. And if you have any questions or comments, please contact Ylva or me. Thank you very much for listening.